All right, so if you're trying to, it's asking you to factor, oops. So we need to put this into factored form. That looks lovely. I'm going to read that. So if you have something like this, 3 times x plus 1 all squared minus 9 times x plus 1 minus 12. So this isn't in factored form because remember we said when it's in factored form you have something times something else, right? So everything's connected by multiplication. But here we have some things connected by subtraction, right? And so I want to show you a way that we're going to be talking about later on too. So I want to introduce it now because I think it's going to help you with some things that we'll be talking about in the future. Because, I mean, some students ask me, well, can't I just, FOIL out this x plus 1, distribute the 3, distribute the negative 9 through, get this big long polynomial, combine like terms, and then factor it? And you can. Okay, that is a perfectly good way to do it. However, there's going to be some things that we are going to talk about where you're not going to be able to do that way. And this is called substitution that I'm going to be showing you. Okay, something called substitution. So what we're going to do is notice how in both of my parentheses I have the same factor. I have that factor of x plus 1. So I'm going to simplify this so it will be easier to factor by letting, so I'm going to say let u equal x plus 1. And where I see the x plus 1s, I'm going to replace it with a u. And again, this is just to kind of make it easier for us to try and factor it. So I'll show you what I mean. So if I take out the x plus 1s, and put the u in instead, right? Get this. All right, and now I look at that and say, oh, that's not so bad. I've factored things like this before. I can totally factor this. All right, what would be the first thing that I'd want to do to factor this?
Take out a 3.
Yeah, right? You see we have a greatest common factor of 3. So let's factor that out first. So if I factor that out, I'm left with u squared minus 3u minus 4. All right, so this doesn't look so bad. And now I need to factor that trinomial more. All right, so u times u is u squared. All right, and remember I can go straight to that hippobutts like I talked about before because my leading coefficient's 1. Right? If it was something different, I couldn't do that. All right, so u times u is u squared. What times what is negative 4? That adds to be negative 3. Well, if I have 4 and 1, 4 is negative, 1 is positive. All right, that will give me that combination. All right, so now remember that I had x's there, though, right? I wanted to know what this factorization was with the x's. I put the u in just to make that factorization easier for me. But now I'm going to take that x plus 1 and I need to put it back in. So I took it out, but I've got to put it back in for my answer. All right, so when I do that, I'd have 3 times, whoops, in place of u, all right, I'm going to put my x plus 1, and then I still have minus 4, and then in my other parenthesis, I'll have x plus 1, and then plus 1. All right, so is everybody seeing what I'm doing so far? So I took out the x plus 1, so I could factor it easier. Now I got to put the x plus 1 back in. And now I need to simplify this. So it's not all the way done yet until I simplify what's inside there. So I'll have 3 times x minus 3, right, when I combine those together. And then my other parenthesis, x plus 2. Right, so now it's in factored form because everything's connected by multiplication, right? 3 times this times this. All right, questions on that? Because like I said, there's going to be something kind of like this that you'll see on the week 5 review. We'll talk about U substitution more in detail in a few modules, but it's good to see it right now. And just try it out. All right, so I'm going to give you some problems that I want you to try here because I just want to see how people are doing with these. So I'm going to write these down and then go ahead and just get started on trying these. Okay, so I'm just going to put try these. All right, so first one. Okay, let's look at one solving polynomial problem here from 4.8, and then we'll take some questions on some of the applications that you want to work on for this. So on this, whenever you're solving these polynomials, you want to make sure that you're putting them in descending order, and you want everything on one side of the equal sign. So basically you need to get it set equal to 0. So if I'm trying to put this in descending order so that everything's on the left-hand side, my x to the third needs to be written first because it has the highest exponent. And then I'll go my next highest is my negative 2x squared, right? So I'm looking at the exponents there. And then I'm going to go ahead and subtract my 63x over so that everything's on the left side, right? And equal to 0, right? So I've got a power of 3, power of 2, and then power of 1 on my exponents, right? So those are in descending order. And then from here, we're just going to be factoring it like we've done in, pretty much most of this module. So first thing that we want to look for is the greatest common factor. And I can see that x can come out of everything. And when I divide x out, I'm left with x squared minus 2x minus 63 equals 0. Right? And now I want to see if I can factor that trinomial more. So keep the x out there. And I can go straight to hypobutts because my leading coefficient is a 1. So x times x is x squared. Right? And then what times what is negative 63? That adds to be a negative 2. Well, I know that 9 times 7 is 63. To get that negative 2, I'd need a negative 9 and a positive 7. Okay. And now from here, so up to this point, pretty much, you know, it's been pretty similar from what we've done so far, but this is where it goes a little bit different. So to solve for these polynomials, right, if we have these three things multiplied together to be 0, well, that means that, you know, one or all of those things need to be 0, right? And so what you're going to do is you're going to take and set each part equal to 0. So I'll take my x, right? Maybe I'll put that into parentheses too, just to make it a little bit more clear. So I take my x, put it equal to 0, and my x minus 9 equal to 0, and my x plus 7 equal to 0, right? So I take each factor and put it equal to 0. And then I just solve each one out. Well, x equals 0, right? There's nothing to solve there. X equals 0 will be one of my answers. Then I need to add a 9 over to get x by itself here. So x equals positive 9 is another answer. And then I subtract the 7 over. So x equals negative 7 is another answer. Now notice I come up with 3 answers. And I want to point out that it's good that I came up with 3 answers because my highest exponent, right, was a 3. And so that tells me I'm going to come up with at most 3 answers. Now, sometimes on these, they're not always real, like in the real number system, and so you might not always come up with 3 answers. But that's the most, and that's usually what you'll get. So if your highest exponent is a 2, you would expect to have 2 answers. If your highest exponent was a 4, you expect to have 4 answers. Okay? And let me also just say, like, if we had something like this, right? And if you're setting each part, so this is just something separate here. So if I had this, and I set each part equal to 0, right? There is nothing to solve for on this 2 equals 0, and that's nonsense. There's, you know, you can't do anything with that. So if it's just a number that you have pulled out as a greatest common factor, you don't need to worry about that as part of your answer, right? Because if you foiled this back together, right, you'd end up with your highest exponent would be an x squared because you'd have this x times x. So you expect to only get 2 answers from this. And those answers would be x equals negative 2 and x equals positive 1, right? Because only if you factor out a variable, like we did on this first one, right, will we have an answer for that one. Does that make sense what I'm saying? Can't tell. Okay, so maybe you're saying yes. All right, any questions though? Like what can I clarify more for you on this example about how to solve these polynomials? Okay, then let's go to your questions that you have on the homework. What things do you want to look at? Here were the questions about the Pythagorean Theorem. No questions about some area ones. All right, question 8. Let's take a look and see what that one looks like. All right, well, the one that's coming up for me, question 8, and tell me if this looks like what you are thinking. Is that what you're thinking, Jordan? Something like that? Okay, awesome. Just want to make sure we're thinking of the same one there. All right, so when you're solving ones like this, remember how I said above that we want to get everything to one side and put the other side equal to 0. That's what you've got to do on solving any kind of polynomial. So with this one, if we try and subtract the 8 over here, we're not going to be able to combine it together with those two factors unless we FOIL these out first. So that's what we're going to end up doing, is we need to FOIL it first. Okay, so when I do that, I still have -8 on this side, and then I'll have w squared minus w minus 10w, and then plus 10. Right? And then it doesn't matter which side I get equal to 0. It looks like it's going to be easier to get my left side equal to 0. So I'm going to go ahead and add my 8 over, and now I can add that with the 10 to get that together. But I can also combine my w terms. So I'm going to do that in the same step. So I get 0 on the left side equals w squared minus 11w, right, plus 18. And then from here, I need to look and see if I can get that factored. So now it's equal to 0, so now I can factor it so that I can set each factor equal to 0. So w times w gives me my w squared. What times what is 18? That adds to be -11. What do you guys think? What multiplies to be 18 adds to be -11? Yeah, -9 and -2, right? So multiplies to be positive, 18 adds to be -11, all right? And so then the last step that you have to take here, it hasn't been solved yet. We factored it, right, to help us get to the solving, but now we need to set each part equal to 0 and then solve those two different things. So I'll add the 9 over. So w equals 9 will be one answer. I'll add the 2 over. So w equals 2 will be another answer. And I expect to come up with 2 answers because remember, my highest exponent here, right, is a 2. So that's telling me I should come up with those 2 answers. Right, so +9 and +2 would be your answer there. And you can check these also, just like we've done with any kind of solve problem, right? So if I'm checking my, w equals 9, and just go back to the original one here. So I have -8 equals w, or sorry, I meant to put 9 there, 9 minus 10 in one parenthesis, and then 9 minus 1 in the other parenthesis. Well, let's simplify this side more. 9 minus 10 is -1. 9 minus 1 is 8. And if I multiply those together, I get -8. So that checks out. -8 equals -8. So I can tell for sure this works, right? And if I did the same thing for w equals 2, I'd see that that one works as well. All right, so always think about doing that check. If you're, feeling unsure, is that the correct answer? Am I doing this right? Right, you can always check those. Awesome. So here's a parabola, right? And so if we're trying to figure out when is it going to cross the 288 feet, well, it does that in two places, right? On the way up and on the way down. So yeah, maybe a little bit of the wording, if it was, it made it sound like it was like, when is it first going to hit that 288 feet, the way it sounded. But usually if it's asking, when is it 200, how many seconds would it take to be, 288 feet, it's really meaning, both of those different answers. So, because it is going to be a parabola, and so it will at, a certain height have two different times to it. Does that make sense?
Yeah, it does.
Okay. What are you meaning, Jordan?
Exactly that. Like, it can go past the point twice.
Okay.
So it's going to be two answers. Yeah, that was confusing, but yeah.
Okay. Yeah, but sometimes, so the one that I was going to work through with you, one of the answers is going to be positive and one's going to be negative. And if that's the case, then you would only pick the one answer that's positive. So let's look at this one and I'll show you what I mean. Because if you get two answers that are both positive, that's great. Maybe this is at 3 seconds and this is at 5 seconds or whatever, right? I'm just making up those numbers, but just saying at 3 seconds it would hit that height, and then again at 5 seconds. But let's look at something like this. So say that you're given this this function. So h of x equals 16t squared plus 80t plus 224. Right? And so basically the question on this, or the story problem, saying that there is a flare that's launched upward with an initial velocity of 80 feet per second from a height of 224 feet, right? Where h of feet is the height at a given time, and t, right, is the time. So just understanding what each of those variables represent is really important. And they give you the, information that you could write this out with, but they're never going to ask you to write these out right now. This negative 16, does anybody know what that is? Because you see it a lot on the problems. You have an idea? What would that negative 16 represent? Think about if you throw something up in the air and it comes back down. Why does it come back down?
Gravity.
Gravity, yeah. So this negative 16, you'll see in a lot of the problems because it's the Earth's gravitational pull. If you had to, a problem where you were dealing with something on the moon, it wouldn't be negative 16 because the moon's gravitational pull is different than the Earth's, okay? But the Earth's gravitational pull is what this 16 is there for. But anyway, so that's kind of, just to help you understand what these different things mean. So we're saying, so here is, so there's this flare, right, that's being launched, and it starts the launch at 224 feet in the air. So here's 224 feet. And so from there, it's launched up, and then eventually it's going to come back down, right? And it's going to hit the ground here. Right? So this is like maybe like some building or whatever that it's being launched from off the top of that building, but at some point it's going to hit the ground. Okay, and so then on this one, that's what the question is how long will it take for the flare to reach the ground. All right, and so what you have to remember here is the ground, and this is what is not given and is just kind of understood. You've got to think of the ground is when the height is 0, right? So height equals 0 when it's talking about when is something going to hit the ground, right? And so that means, right, so it's taking off, right, from this, you know, it's already 224 feet in the air, goes up a little bit higher, and then comes back down. So how long is it going to take to reach the ground? So in place of h of t, I'm going to put 0, because that's the height that I want to know, right? Okay, and then what am I going to do from here?
Factor out a GCF.
Yeah, right. And oftentimes on these, there will be, you know, something nice that factors out and stuff. You know, check for that negative 16 first. Remember, if that first term is negative, you want to pull that out as part of the factorization. Does negative 16 divide into each of those?
Yes, it does.
Okay, so what's left there when I take the negative 16 out?
T squared minus 5t minus 14.
Awesome. Okay, so I just factor that out. And now I want to look at that trinomial and see if I can factor that further. All right, and so I have t times t. And then what times what is negative 14? That adds to be negative 5. Well, I know 7 times 2 is 14. If I make the 7 negative and the 2 positive, that will leave me with a negative 5, which is what I want. All right? Okay, so then I come up with, remember here, if I'm setting each part equal to 0, right? Remember this stuff, that negative 16 equals 0, that's just nonsense, right? There's nothing there to solve for. I don't need to do that, right? But on these other ones, I do. So I've got t minus 7 equals 0 and t plus 2 equals 0. Well, when I add the 7 over, I get t equals 7. So that's saying 7 seconds it'll take to hit the ground. Here, if I subtract the 2 over, it's saying it'll take negative 2 seconds to hit the ground. Well, how is that even possible, right? It can't take a negative amount of time, so that's why we have to exclude this one, right? So it's called an extraneous solution because we don't need it in the context of this problem. And the reason why it ends up being negative is because if this parabola was to continue down here, right, then those would be the 2 places that it would be hitting the ground. And so that's what that negative 2 represents. But that's the time before it let go, right? Because here's 0, right, at 0 seconds. Here's 7 seconds. And that's why this is negative 2. So it doesn't make any sense because it was never, you know, could never be there. Right? So your answer on this would just be 7 seconds. You just have one answer for that. It takes 7 seconds for it to hit the ground. Okay, what can I clarify for you there? You know, sometimes it's a little bit strange trying to wrap your mind around what this is saying, what these story problems want you to do. But I think as long as you remember that, you know, things like, you know, how long does it take to hit the ground? That means that you're going to let your h of t be 0. Or how long does it take for it to hit the water if it's talking about you're throwing something off of a cliff into the ocean or something like that, right? That's still going to be your height is 0. Right? So those are important things to remember for these stories. Just to make sure. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. So of course you need to know that in order to do these. And remember that the c is always the hypotenuse, which is the longest side of the right triangle. Right? So this is the hypotenuse. And then these are legs. Right? Is what they call them. Right? So the one just opposite that right angle is the hypotenuse. Right? And it's important that you know which one's which. It doesn't matter which leg you put as which leg, but the hypotenuse has to be, something kind of different here. So if we have this problem that says one leg of a right triangle is 7 feet longer than the other leg, the hypotenuse is 13 feet. Find the dimensions of the triangle, right? So, actually, let's just find x. I'm trying to remember how they, just make sure they worded that the same way. Yeah, I guess it just says find the length of the legs. All right, so when we're setting this up, right, let's just draw a little picture to help visualize what it is we're dealing with here. Right? So I know the hypotenuse is 13 feet, so I'm going to go ahead and write 13 there. And then one leg of the right triangle, right, I don't know what that is, so I'm going to call it x. But the other leg, right, it says is 7 feet longer. So whatever my x is, I need to add 7 to it. So I've got x and x plus 7 and then 13. So I'm going to go ahead and put those in for the Pythagorean theorem. So I'll put this x in place of my a. So I'll have x squared plus, now I'm going to put the x plus 7 in place of my b, so plus x plus 7 all squared, and then equals the hypotenuse squared, which is 13. And then we'll go ahead and figure this out. We can just FOIL that second part out. So I'm going to write it like this. So I'll have x plus 7 times x plus 7. And go ahead. And when I multiply this out, I get x squared plus 7x plus 7x plus 49. And then 13 squared is 169. All right, remember, and I'm trying to solve for x here. So, and I've got these x squared, so that means I want to get everything over on one side and put the other side equal to 0. So let's get things together that we can get together. So x squared plus x squared is 2x squared. Right? 7x plus 7x is 14x. And then I want to minus my 169 over so that I can set this equal to 0. Right? And so then when I subtract those, right, the 169 minus the 49 is going to give me 120. Right, negative 120. Right? All right, now what do we want to do from here?
factor out of 2.
Yeah. All right, so we'll just kind of take what we've done before. We want to get this factored. So let's take out a 2. And now I'm trying to think of what times what is negative 60 that adds to be 7. All right, so it might take a few minutes to figure out what all those are, but remember, you can work organized, right? And, you know, just keep doing this. Okay, and then I see, oh, it looks like 5 and 12 is my winning combination there. All right, but on this, I need my 12 to be positive and my 5 to be negative in order to end up with a positive 7 there in the middle. So then when I set each part equal to 0 and solve it, all right, I get x equals negative 12 and x equals positive 5. Well, again, I can't have a length that's negative. So I'm not going to use that negative answer. So x equals 5 is what I come up with, but notice it says find the length of the legs. So I haven't done that yet. So don't just put 5 in for your answer on those. Remember, you're going to be doing 5 plus 7 is 12. So the length of this leg is 12, and then the other one is 5. Right? So you should have 5 and 12. Okay. And so that's how you do those type of problems.